Everybody here? All right. Morning, everybody. So today we're going to expand on line wear and some of the things we've learned and noticed, and kind of continue on with that discussion. It's been an ongoing topic for the last 2 years, and want to share a little bit more what we've learned and we're able to share now at this point. There you go. That's all the background. You guys got all that yesterday. I'm going to skip right past it. So kind of a summary of where we've been first is, at this point now, guys, parachutes have gotten easier to deploy and more reliable. So what often in the past prevented us from using like ultra class or super high-end high performance parachutes, by and large, you can get away with. So in general, people that are jumping high performance parachutes are actually jumping higher performance parachutes than they were 10, 15 years ago. And they're using them more often. Stuff that used to be, competition only pilots and guys that were really, really experienced and really tuned in and understood that the gear was really specialized and only for certain uses. Were using the gear back then. Now there's a lot of people taking that same gear and using it every day for video jumps and everyday use. And we're getting away with it by and large, right? It's doable because the openings have gotten better. Reliability on openings is primarily openings, right? Have gotten better, and the skill of pilots has gotten better too. We're seeing less low turns. We're seeing people in general. There's a good curriculum to bring jumpers up and get them into these high performance wings. So by and large, it's been a very positive thing in the sport. But along the way, some of this knowledge that the guys that were early adopters of really high performance parachutes and really small lines got lost. And the biggest part that I think a lot of people missed here is that this increased performance definitely means increased maintenance, and it's not any one thing. It's a lot of different things. Couple kind of fundamental shifts that happened is first of all, it used to be that the highest loading on a parachute was on opening. So if your parachute survived opening, you were good. You're like, yeah, I'm good. I'm good until the next opening. Well, we've all gotten better on openings. All the designers, all the parachutes, we've slowly been learning, and openings are no longer the event they used to be on these parachutes. They're 3, 4, sometimes 5 Gs. We don't see as many really hard openings. It's not the standard anymore. A 10G spike on an accelerometer would be odd on a lot of openings now. At the same time, we're seeing these parachutes being flown faster and harder. And that means that sometimes the highest load on a parachute is no longer at the opening, but in the swoop, right? So you in that recovery arc of the swoop is your peak speed. And sometimes these guys are getting up to 100 miles an hour. Can I get you to scoot over there? You guys are flashing into the screen. And so the highest loading on these parachutes is now at the very end of the jump, at the bottom of the swoop, at the most critical spot for safety, right? At the same time, we're jumping not only higher performance parachutes, we're jumping them at higher wing loadings with heavier pilots. 10 years ago, it was odd for me to go on a drop zone. 15 years ago, 20 years ago, it was odd for me to walk onto a drop zone and see a pilot that's actually illegal on his gear. It is not that uncommon now. Anybody here know what most rigs your legal limit is? Anybody? Yeah. So how many people do you know that with all their gear are over 250 pounds out the door? There are a few rigs that are higher, just so you know. But in general, most are TSO to 254 pounds, right? So that proportion of jumpers has gone up. People that are right at the limits have gone up. Americans in general and people in the world in general are getting heavier. We're getting taller, we're getting thicker, all of that. So all these converge to create a not a great space for our gear, especially when we get behind on a few things on maintenance. So like I said earlier, higher airspeeds, higher wing loadings. Throw on top of that the recumbent harnesses, and we've had a quantum shift in airspeeds now too. So airspeed is lift, and the recovery that's G forces. Those of you who have made the switch to recumbent harnesses, who here hasn't seen a massive switch in speed in the recovery arc? Who here has? I mean, it's pretty substantial, isn't it? I think the calculations I did, or when we took it into the wind tunnel, it was somewhere between a 30 and 50% savings on drag. So it's substantial. Again, you add that all into softer openings, heavier pilots. We've created a situation where if your maintenance isn't on par, the time that you'll find out is not at a time you can do anything about it. You'll find out at the very bottom of a swoop at the highest G loadings, and that has been a problem. And we need to change a few things and talk about a few things, culturally and with gear, and we can prevent this, right? Like I just said, the maintenance becomes critical. It becomes life or death. I say this to a lot of people, and I mean it. Like, a lot of times we're using these high performance parachutes, and there's a lot of people basically that are taking and making something that's a high performance parachute into a daily driver. Like, that's like taking a Ferrari or a Porsche and using it to drive to work. Doesn't always make sense, right? And I was at PIA last year, and there were some people at another manufacturer seminar raising their hands, complaining about, how can we expect video guys to change their lines 3 times, 4 times during the season to get through the jumps. And I think the response from all the manufacturers, we all thought, was, well, you don't have to. There are options for parachutes that are in that range that could survive 500 jumps without maintenance, right? But routinely, the pilots, you guys, are choosing to not purchase those parachutes and to purchase the higher performance. So first of all, we have to all kind of recognize that, hey, this is a decision at the fundamental ground level of pilots. Like, if the reliability is what you really need, and you need the ability to stretch it out and not do the maintenance, be honest with yourself and say, like, okay, look, I maybe the high performance parachute isn't my daily driver. Maybe I have one, but maybe I go ahead and get something like a Gangster for some of my work jumps. If you were mowing lawns and had a lawn service, you wouldn't tow your truck or you wouldn't tow your trailer full of mowers and equipment with a brand new Porsche. You'd put it behind a big truck, because that does the job better. So maybe thinking a little bit about what does the job best is something we need to think about as a group. So as part of this, we've been looking at lines. We haven't stopped. Fast forward, we had an incident in Dubai. A gentleman lost his life, and that got everybody looking at stuff and got a lot of us talking. So we're talking to other manufacturers. We spend a lot of time researching line materials and saying, okay, look, are the line materials we're getting, are they up to snuff like we thought they were? Is there a problem? And we spent a ton of time looking at that, and I think that we actively figured out that there isn't a problem, right? We have good line materials. There has been no change in the material quality. We've yet to find a substandard group of materials. And even when other manufacturers have thought maybe that they had some substandard materials, I think their conclusion was, after talking to these guys, is that they were just acting in an abundance of caution, and it turns out it actually wasn't a substandard material. So we've brought on new manufacturers, new line suppliers, and we're working with them. But to kind of summarize, like, there's different braiders on these lines, but the general fibers, like Technora, all comes from, you buy Technora from 3 different braiders. the fiber itself all comes from one single supplier, right? Tianjin. Same thing with Vectran. You buy Vectran, you may be able to get it from 2 or 3 different braiders, but they're all buying the fiber from one single source, right? So the idea that there's bad material that would only affect one supplier or one location, just it doesn't pass the sniff test, and it hasn't shown up in the data. So, but we've continued to see people like lines are a focus of a lot of people's attention, and so we're paying really close attention to some things, and we've continued research on looking into, okay, we're seeing increased wear on some stuff. It seems like sometimes, like, why is it showing now? Besides the cultural stuff, like what are other spots that we can be looking for additional wear? And traditionally we've said, okay, look, it's primarily the slider, right? It's that flapping, and that still is the biggest driver. And again, like we found earlier, when you mix in sand and dirt into that mix, that it definitely accelerates that wear process. But as part of our focus and paying really close attention to this for the last couple of years now, we've begun to notice a couple other things that are popping up as wear items that haven't entered the conversation. Again, we're talking about this with at least one other manufacturer, and this year in particular, we've all come to the same conclusion. Like, hey, look, we've identified something else that seems to be showing up. And primarily, it seems to be wear from other sources, not from slider flapping, but maybe from line on line or line on container wear, right? We're seeing damage from what appears to be other lines, containers themselves, and how they're stowed in containers, and snags on the containers, or damage from just walking around the drop zone and packing too, right? So at least one other manufacturer's noticed wear from like a line twist. We've noticed it from other malfunctions and stuff too. So I want to talk about this a little bit and hone in on, okay, great, you get your slider, you're checking your lines, but what else do you need to watch out for, right? I know one other manufacturer had a parachute where someone had line twists, and then the very next jump, they had a failure on lines. They checked the whole batch of lines, and it turns out that the material was good. So they had there's a strong correlation there. I don't know if they were able to directly say like, hey, look, for sure it was abrasion on the line. But we have seen some parachutes that came back. We had some parachutes that came back after a malfunction, and that was on essentially a brand new line set after a line twist and then a main reserve entanglement. The gentleman did survive. He did okay, but he did have some parachutes rubbing together, right? You can see that we're seeing line wear in this, that, you know, on that particular, in that area. See, those are broken carriers, guys. That is that line wear that we're saying, hey, pay attention for this and watch out. It's not at the bottom of the lines. It's not where the slider flaps. It's not in the normal spot that we see it. This is up in the middle of a line, above a cascade, right? So lesson number one is, after you've had a malfunction or you've had to cut away, you absolutely need to inspect your gear. That is a significant wear event. It's not just a wear event during the malfunction. You can't just say, oh, no, nothing rubbed on the lines, I'm okay. You perhaps cut away a parachute and it landed in a tree. You don't know if a carrier got snagged when it got pulled out of the tree. You don't know. And the parachute's been out of your control. So this is the time to not just get it back together, pack it up, and go jump as soon as possible. This is the time to hang it up and do a detailed inspection. So after malfunctions, all of us are starting to see some different damages on lines, right? Another place, so a little background on this one. Took a little while for us to share this because I wanted to get permission first. But This video is from the gentleman that passed away in Dubai. This is the line set prior to his incident. Okay, guys? You see that line? That's the exact same line. It appears to be the exact same line that failed during his fatal jump. Okay, that's the left center A. You can see what the condition of that line right there, right? See what it's right next to inside of a pack tray? We're currently investigating this. I don't have a valid conclusion for you yet, but the correlation is strong enough. It's time to share. And it's time to start talking about, hey, what's going on inside your containers when you're packing these things. You're going to get a chance here. This is him recording it. He sent this to Jason after
I think could be a possibility. I don't know if it's like if the line is really packed in the corner, but you need to have a lot of tension on it. Like it doesn't feel usually when I pack it myself, I don't pull that much. But let's say was push, maybe could have snagged on the part of the main factory.
Okay, we say this we're not trying to CYA or blame anybody for anything, because the rig is coming back to the manufacturer, and I'd be really surprised if we find a problem with the rig. I don't think there's anything out of the normal there. I don't know. We're investigating still. It's coming back. We'll be reviewing it along with the manufacturer and looking at it. But the thing here is so that we can all learn, like 10, 20, 30 years ago when that part of the rig was designed, the smallest line available was a 500 micro line, right? Now we're jumping 400 Vectran, significantly smaller. It can get in places that it didn't get before. We're packing rigs in tighter. We're trying to get the smallest rig we can get, so we're packing gear in there. And that's going to result in lines being pushed against things in your pack tray harder than it would have in the past on a looser pack job. You also notice that lower part of the line is right where they're already subject to a lot of wear. Okay.
Yeah.
So this prompted me to go look at a lot of stuff that we have laying around and how we're packing our gear in the test rigs we have, because we kind of have rigs from almost everybody. We've got a ton of different gear laying around in our test room and with some of our athletes, and kind of start paying attention to it and go, hey, look, well, what are the different wear items from a deployment? Because I'll show you in a little bit, but we've seen damage to lines. We've seen broken lines from entanglements during the deployment and from rubbing on items in the pack tray during the deployment, right? And there's some good signs of that. They initially got blamed on the lines and slider, and upon investigation, in fact, one of the guys in this room went and looked at it and got me these pictures. And clearly saw that, hey, look, it wasn't a line break. It wasn't a traditional line break. It was an entanglement, which can, you could have entanglements on a lot of jumps and they can be clearing. So again, inspection of not just the lines, but the other parts of the gear is important. It'll give you signs on some of this stuff. But as we started looking at this, I'm seeing, like there's a ton of spots where when that parachute comes out in 1/10 of a second, those lines, those open lines, can get drug across a lot of things that could cause abrasions. A sharp binding tape, pilot chute, or a closing loop attachment point, stuff like that. Things that are, when particularly when something's ripped across them really quick, could be very abrasive and generate heat, or be abrasive and damage fibers. And if you think about the mechanics, what's happening in your containers, most containers, that bag is set in and then kind of rotated or set in flat, such that when the bag and pilot chute tension, the first thing that happens is the bag rotates as it comes out. So when you're packing your container, look at that container and think, am I sandwiching that bag such that it's pushing my lines against something that when it rotates, it's gonna rake those lines across something, right? because it can't be, we're seeing still increased wear now with hybrid line sets. We see that we've put extra residual strength in some of those center lines that seem to be wearing the most. But going with a thicker line hasn't meant that we don't see wear. It just means that when we see wear, instead of being left with a 200-pound residual strength on your line, you're now left with a 300 or 400 or 500-pound residual strength on your line, right? So the wear is less consequential, but we're still seeing wear. And some of the things I'm saying, like, you got to start paying attention to. And again, I'm not saying these are causing them. I'm just saying you need to start watching. We need, as a community, to start paying attention to this and trying to pack a little bit differently so that we're avoiding any possible problems. Because there's 1,000 different ways to put these bags in the containers, and there's 1,000 different ways to close this, that some of them could be problematic looking at it, right? We got internal riser covers, we've got dynamic corners, we've got pilot chute attachments, or not pilot chute attachments, I'm sorry, closing loop attachments inside the pack tray. This is a rig I pulled out that we had packed in our area here. You see that right in here, the lines run all the way down, and someone's taken excess and it's all coiled up here. So that bag's going to get set down on top of it, and all that excess is folded up at the bottom and sandwiched against the bottom of the container in a spot where, as that bag rotates, there's a good chance it's going to rub that against the inside of the container. If there's something down at the bottom of the container there, that could be a cause for concern. Some containers there is, some there's not. See here, that's what I'm not even going to go brands on what these are. There's 4 or 5 different brands in this that I took pictures of. But you can see, again, multiple different brands have this small binding attachment there. It's a common way to close containers and to create that rectangular enclosure for your deployment bag. To me, it seems like something that I'm taking care now to avoid. Another source of damage that we're seeing that I think happens more often than looking at people's deployments when they have a problem and they send them in to me. I see evidence of small entanglements that clear a lot more often than I think people will give it credit for. I saw this particular rig, and I think my first talk was my first inkling when I watched the deployment is that there was some sort of entanglement that we're not seeing. And Dylan ran over and looked at it. It was near him and sent back these photos. So you see, it's an inside A. It broke. It broke in a very similar spot, right above the finger trap, bottom part of the lines. But on closer inspection, you can see there's a really good line burn right there. That's on the attachment. You see where it lines up. Again, those come around the corner. That broken line is right in that area. These can happen and clear pretty often. Occasionally I'll get people send me an opening. What do you think caused this? And all I can see in the opening is one line loaded before everything else, and it's a lot shorter. Clearly, and it's kind of sticking out, and the others are going around it. And when I see that, it's like, well, what caused that line to get loaded first? And a lot of times, the only explanation I can come up with is an entanglement. Now, I don't have outside video on a lot of them. I don't have the ability to examine the rig both before and after, because not every line burn gives a clear picture like this. This is classic line burn, though. This is what you see like that charred whitish color. It looks really similar on parachutes as well. They're not always smoking guns like this, but they can be small wear events and serious wear events, right? And if you're not paying attention, they can get you. So the other thing to note here is, even if you have a funky opening, things weren't quite right, take a little bit of time, stop, look at your gear. There may be evidence of it, there may not. There may be a wear event on your gear, someplace in the lines, or someplace on a riser, or someplace in your container. That when things are out of the ordinary, stop and investigate. So a couple different ways of routing the lines, right? So we've got here up in the upper left, a lot of people will pull the lines out because there's this myth that you have to have a bunch of excess line before they enter your bag, right? Well, probably half the people in this room, I guess, are jumping some sort of semi-stillless bag, right? Okay. On a semi-stillless bag, you no longer need that excess line. You can keep that line, as much of it as you can, packed in your bag. And all you need is enough that your risers don't get put in a bad spot, and that they don't wrap around the lower corners, but don't spool out 2 feet of line and put it in your container. Because the reason we used to do that on bags with rubber bands that go all the way up is that you wanted to give it a chance to build speed without resistance, right? So you wanted the bag and you to separate and build enough speed, differential speed between the two of you, that when that first rubber band engaged, it wasn't enough to like lock it up and slow it down and create a stop in the motion. We wanted it to continue on fluidly, right? Because if it stopped, that was kind of a chance for it to twist and load and kind of cause a line twist. So the theory was always give it a little bit of runway there so that the speed can build up. Well, the payout force on a semi-stillless bag at that point is essentially zero. So you no longer need this extra line to ramp it up and give it the ability to overcome that first stow. So I would urge you guys to find ways and work in conjunction with representatives of your container manufacturers, but find ways to safely keep as much of that line as you can in there and pull out the minimum amount needed to cleanly route your risers when you're packing them in your main tray. Again, each container manufacturer is going to have different recommendations on that because the bags go in differently in each of these. Some of them you put the bag in flat where the pilot chute's pointing towards the top of the rig. Sometimes it's pointing straight out. They all have different recommendations, and adhering to that, but putting as little line as you can into the bottom of the container is probably a really good idea, because what we're seeing is that line has places to catch and rub, right? And that rubbing may be causing some of the wear. I just took this picture out of the Vector packing manual, but I wanted to illustrate that when you put the lines, you see the lines down here, they're kind of all coiled up. Oops, apologize. When you rotate that bag, and especially if this is a really tight pack job, you're really sandwiching those lines down on the bottom of that container. And as you can see, when that bag comes out, what happens first? Rotation. What's at the bottom of that rotation? What's getting raked around in there? Lines. If your lines are super critical and you're already on the edge, this is another wear spot, guys. This is definitely a wear spot. Is your container too tight? You know, are you absolutely stuffing the maximum in there? This is going to be a bigger concern in those cases. Right? So we're just looking at other sources. What are other sources of wear, right, guys? So just in an effort to be vigilant. And the more I look, the more I see. So this is my rig. This is one of my rigs, my containers, personal. This is why I like a really simple container. You see that mine displays completely open. This is just my personal preference, but when I'm testing, there's not a lot to rub here. There's not a lot to sandwich the lines in a weird spot. I don't have internal riser covers. I don't have anything that this stuff can snag on. This is how I personally jump. And I've chose to jump this way for the last decade and a half, for a lot of reasons. But I found that my personal results are, and I guess this is anecdotal because I don't have data on this, but anecdotally, my personal results are is that my openings, the simpler I make all this stuff, better my openings are. There's no seams there. It's when that container opens, it's wide open and the bag just basically is free to go. So let's talk now a little bit more about wear from slider rings and other stuff, because I think one of the things that a lot of people aren't realizing about wear and tear is that, hey, your lines wear, but there's other parts of your deployment system that also wear out. And part of realizing that is if you look at these lines, like that black on the lines, you've all seen it, right? What is it? It's metal from your slider grommets or your rings. It's metal. And the more sand you get on your lines, the faster they turn black because the more abrasive they are. I mean, if you think about what sandpaper is paper, which inherently is not going to have any effect on something nice and hard like a stainless steel. But you embed silica sand on it, and you can now smooth out a surface and change the surface roughness on wood, metal, all kinds of different stuff, right? So the same thing happens when you take Vectran or Technora and you embed it with sand. It starts sawing away at metal items. That's a set of rings with about 1,200 jumps in sandy environments. You see that gouge right there where the line sits? We polished it. It's been polished, and there's no rough edges there. But it will wear away. Your rings and your grommets are going to wear out someday. We're seeing more and more where people are jumping this equipment, and it's like, hey, look, this is at its expected lifespan. And people seem to be blown away that, well, it's metal. Like, it doesn't wear out. It's good forever. It's like, well, it is if it's like steel, if it's just loaded and unloaded. Essentially, the fatigue life on steel is almost infinite, right? But the abrasion life is not infinite. You know, a beam can be bent as many times as you want, but a brake drum or a brake rotor, because it's getting friction on it, just like your slider grommets and your RDS rings, they're going to wear out, and you're going to eat material away. So it's important. I don't think anyone talks about this, but it's important to realize that all these are wear items. It's not just your lines. It's your lines. It's the tapes and stuff in your container that wear on your lines, but that stuff's also going to wear. And then things like slider rings and grommets, they're also going to wear. And there is a time where it's like, hey, look, you look at that slider ring and it's not only out of round now, it's got grooves, right? And those grooves are going to push the lines into that spot. And they're probably going to increase the contact area on the line. And if there's particulate stuff in the lines, it's going to increase the friction. So you're hitting the point where these are showing enough wear that they're actually going to probably increase the wear on your lines. So realizing that these metal items and these other items in your container stuff are also wear, and there is a finite lifespan on them. You can increase that lifespan with care. So a lot of people, what they don't realize is when a set of rings comes in to us, we do a reline, we take the time to clean them up and polish them every single time. It's one of the benefits of sending it back to the factory is we're checking things that other people aren't looking at, right? Average metal in most of your rigs is a 316 stainless. It's austenitic and non-magnetic stainless steel. Okay. The 3 Series is a workable stainless steel that it's called marine grade, right? Great stuff. Most of the stainless stuff is from chromium that's being put in there. And the downside of it is it's not crazy hard. It's not the hardest metal out there. And there is no process there's no heat treatment. We can't like make our rings and then go, okay, let's put it into heat treatment and really toughen this stuff up and make a surface hardness like diamond hard. So you end up with a metal that is reasonably soft. That's why you get some of this abrasion. Alternately, if you were to try and make these rings out of a four series stainless, which is much harder, the cost of the ring would not double. It would be exponential, right? Because it's so much harder to machine, so much harder to work with, things like that. We do get some benefits from some of the working we get. We work on them. Sorry. There's no heat treatment, but the machining, when you machine it, this material tends to work harden a little bit. Bending, machining, and forging do harden the surface a little bit. And so when you see like a machined ring against a forged ring, the forged ring will have a little bit harder surface, so you'll get little dents sometimes. But the way we deal with this, and probably the best way we found, is to routinely look at your rings. Check out your slider. Your slider, same thing. The grommets on that slider, if you're seeing rough spots, you can pull out a grommet and replace it. You gotta need some special tools, so we would have to do it for you, but it can be done. You can also fix them. I'm not urging you guys to fix them by showing you this, but I'm telling you that we do on a routine basis polish and grind the rings. It's part of our regular inspection for a reline. And the idea there is that you drop them on the ground, all kinds of, or they get banged against something else or banged against each other. There's all kinds of ways that metal can be damaged. And so it's just important to pay attention to it and care for it, because if you got a bunch of dings on, particularly on the inner ring of that radius on the RDS ring, it can cause increased wear. And so one of the things we do is there's a sanding drum we use, and this is literally right over there. This is a picture of the stuff we use. And every ring we get in here on a reline gets a sanding drum. I believe it's a 300 or 600 grit, followed by a Scotch-Brite that, again, progressively smoother polishing. And then we use a metal polish and polish it. And literally polish the internal of every single ring, because it is important and it does change the wear. A couple side notes on this: if you end up doing it yourself, A, contact us. We can tell you the steps. B, make sure you get all the polish cleaned off the ring, because putting polish into your lines is going to be pretty bad, because the mechanism that the polish works is abrasion, right? So it's going to kind of do what sand does to your lines. So it's really important that they get washed and thoroughly cleaned afterwards. So that's kind of the thing, is I just want to increase awareness on these different items. It's not just your slider flapping. It's not just checking your lines for wear and catching them right before you jump them. Like, there are other spots to watch. You can start predicting line wear and seeing where your line wear is coming from. Are you seeing evidence on your slider grommet? Are you seeing slider evidence on your RDS rings? Are you seeing evidence in the bottom of your container? Have you had malfunctions? All of these things can give you clues to, hey, look, I'm either experiencing line wear, or I think I need to start watching for it because I'm seeing evidence elsewhere. And so the idea of this seminar here is to increase that awareness, give you other places to look other than just looking at your lines and being scared, and just a general understanding of where we're at. Some of the things we're working on, as you guys probably saw yesterday, we're always tinkering with different ideas to give increased safety margins, right? Our hybrid line sets. Our hybrid line sets are not an attempt to make lines last longer. It's important to understand that. Hybrid line sets are not an attempt to get more durable lines. The idea on a hybrid line set is to push your failure point, if you do take your lines too far, to a safer failure mode. So we've taken the lines that are high wear and high consequence and made them stronger, while we've left other lines that can be higher wear lower consequence and let them stay the weaker lines. The idea is that if you do have a failure, the probability of your failure being less catastrophic is better. And specifically, like on an opening, let's just say you're breaking a line on an opening, your front A's, because that's a really critical line, right? The A lines and the B lines are really critical to stability. They're stronger, but your front or your center C lines are not stronger. We didn't increase the strength of those lines. If we were trying to just simply add durability, we would have done that as well. We didn't do that also because that may affect tension audibility and other reliability concerns on your parachute. But primarily we did that because we're trying to set up a failure mode that is less consequential. And so that's an important distinction that I think a lot of people, and we haven't necessarily talked about as much as we could, but it's an important thing to realize is that it's not an attempt to give you better durability. It's an attempt to put the safety margin back into a spot that if you do go too far, hopefully it puts you in a safer failure mode. It may not, especially if you disregard and try to jump till they break, which is, I hear people say that I'll fix it when it breaks. Again, like I said earlier, modern parachutes don't break at the lines don't break at a safe spot anymore. They don't break at a safe mode of flight. They break in a critical mode. So, because of that, your life definitely depends on your maintenance. And like that one more Saturday afternoon, not jumping tomorrow. One more, and I'm just going to go ahead and send the line set in. I'll send it in on Monday. If you notice it, stop jumping it. It's not worth it for one more jump. We've all said it and done it, and it needs to stop. High performance is high maintenance. You have to accept that. The smartest guys that are in the industry that I see are buying line sets and they're keeping a spare on hand. So, and when they swap, they put that on, they order a new one because there's a 2-week wait and maybe they don't want to wait. And so to keep themselves out of this maintenance bottleneck, they just have a spare set sitting there. Now, you go to a racetrack, pull up to a racetrack and watch guys racing cars. They brought spare tires, right? You know why? Because they know they're going to wear them out and they want to have a spare set that they can change so they can keep racing. Lines are kind of the same thing. If you're going to drive a race car or you're going to drive a high performance parachute, bring a spare set of tires, have them ready. And the last thing I want to leave you with today is like, there's a lot of different wear points on your parachute lines. It's not one spot. It's not a simple thing. So often in parachutes, people always want to know, well, what causes this? And the answer is almost always, it depends, or there's a lot of things. And that the lines are the same thing is there's a lot of different things that can cause line wear. It's not a simple, oh, just your slider. You've got to look at the whole picture. You've got to look at the whole puzzle. And for each of us, it's going to be a slightly different answer. So, yeah. Do we have any questions? It's pretty short to the point, but it was kind of eye-opening for me to see that it isn't one single answer, because we get micro-focused sometimes on one thing, and to start broadening the vision and seeing, okay, look, there's other things going on. They're fairly widespread, and I'm seeing them in a lot of places. It was pretty good information. Certainly.
Do you rotate your bag in your personal container, or do you pump it right straight off the backside of the line?
The question was, do I rotate my bag in my personal container? Yeah, I do. But my lines don't. I don't have any spare line in the bottom there. And they don't. The risers don't go back into the corner of the bag. I don't run them back to that seam. I don't do that because I don't have a seam there, right? That seam got opened up. So if I leave them sitting there, when I close my container, I'll have little bits of line sticking out, loose line, and that's really kind of a bad thing. So I generally tend to kind of beam in at a 45-degree angle, and then they curve back into the bag. You don't want to run them around the bottom of the container on a lot of containers because depending on how it's packed, you can, there are scenarios where the bag can hitch those lines kind of underneath that corner of the reserve container, and that's equally bad, maybe worse. So I typically put them kind of angled in away from those seams. I set my bag in flat. I don't like put it in and rotate it because I don't have that box. You saw my container displays wide open. And I close it, and as I'm closing it, I make sure that the lines aren't getting caught in weird spots like that. I've had other manufacturer containers that they want you to set it in vertically. I've done both. So with today's smaller lines, I haven't been jumping in a container where I have to wedge it in and crank it down. Since I've been jumping small lines, I've had a split open pack tray.
You had said 5%.
Yeah.
There's still that little bit of tape there that looks the, but it's not just.
Yeah, you're saying that your container has doesn't have that full bottom seam. It has a little bit. I'm seeing quite a few container manufacturers starting to do that. I really like that. And I can tell you that early on, even before we started Fluid, I was developing the semi-stillless bag, and one of the number one things we noticed is how the bag comes out of the container. I've had a lot of video of looking back at deployments and that part of the deployment. It was surprising to me. First, how chaotic it was, how much lines are just going all over the place. There wasn't as clean of a method, or it wasn't as clean of a system as I thought it was. And second, how often the bag had a little pause or the friction coming out of the container played a factor on it. And so personally, the less encumbrances I've put between that bag coming out and then a smooth line tension at line stretch where the bag comes off, the less steps and the less encumbrances I've put in that process, the cleaner my deployments have been. And arguably, we're here jumping we're jumping some stuff long before it's really ready for prime time viewing, and arguably has the higher chances of things really going wrong, right? So yeah, that is a factor, and I really like what I'm seeing there. Again, each of you need to look at your rigs and analyze this and go, hey, look, am I creating a problem? And if you think you are, talk to your manufacturer, talk to your rigger, start the conversation. I'm not having this seminar here to tell you guys what's happening in your rig. I don't design containers. I'm not qualified to tell you that. I'm here to start the discussion. Say, look, hey, look, I'm seeing this. As a parachute designer, I'm seeing this. Start the conversation. Start when people are having problems with the job zone. Look at their rigs, help them. Have the conversation. Don't jump to a conclusion. Involve the gear company, because we know a lot of things about our gear, and we've seen a lot of things. And it's amazing the number of times that people invent a solution and a cause out in the field and they never bring it to us. We want to know these things. We want to be involved in these conversations with you guys and help you diagnose and get things working really good for you. So the point of this is to make us all start looking at our gear even closer, and to use this as a chance for education and being better. So does anybody online have any questions? Seeing some guys online. I don't see the comments, but if we have any of those online too. Anybody else have any questions?
Something that has always interested me about the semi-stillless bags, the way that I see most people put the stows in, they'll figure eight it onto the flap and then they'll fold the flap up onto the bag.
Mm-hmm.
And I've always thought that was kind of strange because it puts the lines that are extracting and the lines that are entering the bag up against each other.
Does.
So do you think that would create an extra friction wear point as the lines are extracting?
It's possible. In my experience, having watched a ton of them, so I designed the semi-stilless bag you're talking about.
Yeah,
Um,
and I use one, but I
Yep.
do mine the opposite way. I
Yep.
figure it onto the bag and then put it flat.
I can tell you that in use and in general, I can't tell the difference when I see a line set, which way it's been packed. I don't think that there's enough tension on that to really lock them against each other enough to create that. The other thing is when it's pulled out, ideally it's pulled kind of downward and away from the other lines and onto that cotton shaping strip at the mouth of the bag. So that as it zips out, if there is friction, the idea is that that's where the friction really goes. And so is that a wear point? Yes. Is there an equal wear point on the stows where they rub against each other pulling out a rubber band stow? I think it's fairly similar, right? So let's talk about like, how can I come to that conclusion, right? So what I would look for is evidence of a problem with that is that where that, well, I would look for line wear on the part of the lines that are stowed most commonly, and it would, the highest pressure would be when the most lines are in the bag. So for me, looking at this, if that was a significant wear point, what I would see is probably about that far up the lines. Not here, because most people aren't stowing, not from the slink to here. This is slider and stuff in the container, I think. And then I would expect about this far up the lines to see that be a significant wear point. And statistically, I'm just really not seeing that. When they come back for wear, I see wear and primarily on most of our parachutes in two spots. You see it down at the bottom part of the lines, almost always the worst wear. Then typically you'll see about this far off the line attachments on the A lines, off the B lines and the A lines, and then the C's and D's is a little further. In a spot that kind of corresponds to where the slider sits during that initial snivel. We typically don't see significant wear there. We see some discoloration, but you do get some wear there because it's kind of sitting. There's a lot of movement. The slider's kind of sitting there, and if you watch your lines when the first lose coloring, you usually most people will lose it kind of right there, and then kind of down at the bottom of the lines. We do see some odd wear now and then. That seems to be a pretty consistent pattern, and so that tells me, and this is something I was looking at not just on our parachutes. Back when we were designing the semi-stilless bag, we hadn't even done fluid yet, so we were jumping other people's parachutes, and we just weren't seeing wear in that location. So I know Jeremy packs his semi-stilless bag the same way, and it breaks my heart every time I see it because it's easier to pack on the ground flat. And that was the design intent on it. It's just easier. My thought was always that what you're saying, yeah, they do rub against each other, but in general, it's easier to get a nice S-fold. It's concentrically smaller when it's flat on the ground, and less chances of creating a tension knot or a loop that goes around itself when it's flat on the ground. And kind of the trade-off there was, okay, probably increased reliability was a better bet. That was the thought process we went through, just kind of not seeing evidence of it. But if you feel like you need to do it a different way, you should definitely do that. There you go.
Just curious.
Yeah.
The way it's so the excess lines that force it free back, second it in line
By-
the figure 8.
Bite by bite.
Yeah.
So like so what you're asking is what do I think of it? What do I think of that? Like the Infinity party bag in particular? I think they're great bags. They're a little harder for me to use personally, but I have an Infinity party bag. Kelly's a good friend of mine. They make really good stuff. For me, it's just easier to fold them up quick. That's the only consideration. Look, is the most reliable, the whole idea on the semi-stilless bag was what's the most reliable deployment system we have? On our reserves. you look at the semi-stilless bags and you look at the reserve bags, you'll see the similarities. We didn't invent anything. We just repurposed a great idea. That's all we did. We just said, hey, what's really easy that everybody does and really reliable, right? Let's make it so we can use it every day. And so in the reserve system, it's actually even more like a party bag. I'm a little anal retentive. So me getting the neat folds that I can get when it lays flat on the ground, again, that's the other part, laying it flat on the ground, like seeing that neat cascading line thing is really important for me to feel good about my pack job and be confident when I'm leaving the airplane, which does matter, right? Confidence and gear fear, they oppose each other, and you're going to make better decisions probably and be calmer when you're feeling confident. I learned that when I started base jumping is when you're standing on an exit point and you've got gear fear, your exit isn't as good. You do a lot of things that are goofy, right? And so the little things that you can do to give yourself confidence do matter. So if it gives you confidence and you feel better about it, like how you're packing that bag, you should definitely do it that way. Because we all need to be in a headspace when we're jumping that allows us to make calm and rational and good decisions. And adding stress to that is never a good thing. So there's some psychology in all this too. Like there's, again, you give me a question like, what do you like better? It depends so often. Engineering is always like that. Like design engineering is never a flow chart. It's never a this, then this, then this, then this. It's always trade-offs, compromises, and what's best for you. And it's going to be different answers for different scenarios and different people. Okay, do we have anything coming in online, Cola? I heard some dinging on my. Okay. Anything else on lines here? Have we beat it? Just
Have you done any studies on lines being isolated and exposed to certain, whether it's the dirt and sandy below or a lot of less than line? Obviously, like company packing, of course, but not those areas, but just the lines and some sort of like how much they get impregnated.
Yep, we have. So as part of our original line study last year, that's what we did is we looked at different things. So we looked at sand, clay, salt water, right? Kind of expose the lines to different things. Now, inherently just exposing them to these things, if there's no wear event, there really isn't a change, right? These are the coating on the lines in particular kind of protects them from stuff. And short of UV light, they don't really go bad with time, or just you expose them to certain chemicals, yeah, that's going to be bad. But they're meant to be out in the world. They're pretty stable when they're exposed to just a little bit of sand. The sand just touches them, it's not going to degrade them. The sand touches and rubs on them, well, then we saw big differences, right? And one of the things we did, and I'll refer you guys back to the original line, the line seminar I did. We did wear testing with different contaminants, and we went as far as having Eloy dust sent to us. Rich Labar grabbed a bucket of it, went out, got the caliche for us, and sealed it up and sent it to us. Went and got sand at the beach here. We got salt water, and to be perfectly honest, the worst one we could find was Florida sand. The sharp, angular sand was absolutely devastating to the strength of the line. And those grooves I showed you on this ring, we got the same thing in the equivalent of what we see in about 250 jumps. Where we got a groove about that deep from sand. And when you wet the line and then dipped it in the sand, you really stuck it in there and held it good. Because we tried a couple different protocols. Put one where we just put the line in a bucket of sand and shook it, and that's the first time we saw like really big changes in condition, strength, and wear. The way we evaluated those lines was we put them in the contaminant, and then we ran them through a standard wear cycle. And what we had done is we took a segment of line and we progressively, it has a ring, it's under tension, it has a ring with a normal force on it. A normal force is a perpendicular force, and it cycles that ring or grommet back and forth across the line. And we're cycling it across the flat area with no finger trap and the area with the finger trap. Back and forth, back and forth. And we did that progressively higher intervals until we saw a strength deterioration that was similar to what we see when the lines come back often. And typically that was about a 50% strength deterioration, right? It turned out to be about 5,000 cycles back and forth. 1, 2, 3, 4, like that. So we took that and then said, okay, let's expose these to different wear. It wasn't actually 50%, by the way. It was a little bit higher than that because we don't actually see a 50 is a nice, easy way to talk about it. It's probably actually a little closer to 60, right? But it's an easy number to divide by 2 in people's heads. So we use that so that you can kind of get an idea. And then we started introducing contaminants. And then the way we qualify these, because there's no way to evaluate the lines other than the only way to quantify them. And still, even when you get a set of lines, there's the only way to quantify these for acceptability is tensile testing, right? And then a visual inspection. So we broke them. And what we saw is when you introduce the sand into that environment, it is a lot less cycles to get to that 50% strength. And if you continue the cycles to the same 5,000 number of cycles, the residual strength drops. So you look at it both ways. You know, does it wear faster and does it wear to a weaker point? And the answer is yes to both. Clay was also pretty bad. Not quite as quick to act, but it was bad. Salt, not great, but not as bad as the sand. And water didn't seem to have a huge effect. Vectran's pretty hydrophobic, repels water naturally, right? And Technora, the Technora we use, has a hydrophobic coating on it. So it inherently doesn't also attract a lot of water. Raw Technora is not. It will hold water. But the Edelrid Technora that we use has a hydrophobic coating on it because it's used as a kite surfing line as well. So it needs to be water repellent.
Scott, did you see a visual difference, experience difference in the wear based on different types of water?
You know, when they're really getting line, yes, the answer is yes. Between line types, we definitely saw a visual. We saw a lot more metal filings, and we traditionally do see a lot more metal filings in sand with Vectran. Technora looks a little bit different when it wears. So Technora, typically doesn't get black. You don't see as much filings. And the Technora doesn't change color as much. So Vectran, even if there's not metal filings in it, it turns a gray color, right? Typically see a gray, and you see a distinct coating loss, color change, and then broken fibers, typically in Vectran. It kind of happened in that order. It's not clearly staged. They kind of blend into each other, but you kind of see those 3 phases. And Technora, when you're seeing line degradation, you typically see coating loss, not a lot of change, and then fibers start to break. So in Technora, the nice thing about Technora is it starts out stronger. Size for size, Technora it's got higher breaking strengths than Vectran. As they wear, they equalize out. And Technora is a little bit, it's more important to look at your lines in Technora. They don't show the wear as, you know, there's not flashing lights on it. You need to look for broken fibers on your Technora because it doesn't get the discoloration as well.
Kind of meaning more on like salt versus sand versus clay, like.
Well, when you mix in sand, you inherently, sand and clay, you typically get more metal filings. So you tend to see like the darker color more pronounced. And then a lot sooner, you'll see the broken fibers. Because really what we need to be looking for is not a color change, not just my coating gone. you're looking for those broken fibers, right? And I'm going to go back to a slide that I had here. So here's a good color change, right? We're seeing color change, and we're seeing some broken fibers. This is a hybrid line set. You see the two thicker outer lines and thinner inner lines. But what I'm not seeing there is, do you see a lot of really broken fibers? I bet you anything, we've got these sitting upstairs. We took these off one of our sponsored athletes, parachute, and we'll be breaking those lines here in the next couple of days, because we routinely break them when they come back. And if you guys have a question, when you send in a reline, you're like, oh wow, I'm trying to gauge, I want to gauge what was my line strength left, right? Ask for a line break. It's no charge. We'll break your line, and now you can look at that line and go, okay, look, break 2A for me and send me a result. We'll break it, and you can go, okay, look, that 2A looked to me like it was toast. And maybe it is toast, and you get the number back, and it's like, it started as 580 and you're down to 200 pounds. Now you've got a gauge in your head, right? Next time, get another break, and you're going to get these data points, because it's hard to convey in a picture all the detail that you can see with your eye when you're at the drop zone. And we do this with a lot of people. Like one of our sponsored athletes is like, I'm getting some wear, and it looks to me like a guy, like it's too much. And he sent it in. I said, okay, let's give you a break. We broke it, sent it back. It's like, yeah, you're 480 pounds on your 580 center 2A. Was that too much? I don't know. It's a comfort gauge for you. You have a data point. I don't care. When you think it's time for lines, just be conservative. It's what we want you to do. So kind of a long answer to that. Now, this is where, but let's go back to these guys. Do you see a difference between those and the previous one? Kind of see the fibers there? That's where, that's those lines, if I were to break them right now, I bet you anything, if that's a 400-pound line, I'd expect it to break in the mid threes. We don't have full carriers broken. So you guys know what a carrier is. Does everybody understand what a carrier is? When the weave is braided, there's groups of fibers. Each of those fibers is we refer to as a carrier of group, right? And typically it's a 12 or 16 strand braid. When you get to the point that more than half of the fibers in any one of those carriers is broken, you're really at a critical point. Because what happens when they break typically is, if you can get one carrier to break, to finish going ahead and failing, they all kind of go. Because what happens is, when they're all even and they're all braided together, they spread the load evenly. So this carrier takes 1/12 of the load, this one 1/12, this one 1/12, and they can share the load. As soon as this one goes away, the next tightest one kind of takes all the load, and then that fails, and the next tightest one, and they go. It's called a cascading failure. Tends to be what we see when we break them in a tensile tester. You'll hear pop up, kind of in a quick sequence. They pop really quick, and then there's usually one or two that held on at the very end, but there's almost no strength, because the load you've applied to break those, none of the carriers, once the first one lets go, can support that whole load. So when you're looking at them, you're looking for carriers that are in imminent failure. And usually that's something that has about more than 50% of the fibers gone. So this is maybe 10 to 25% of those fibers. And like, it's wearing. It's significant wear. And you're going to see a strength deterioration from this. And it's a personal choice. Is it time to replace it? What's your use level? How often are you using it? Are these 400-pound lines, or are they 750? Again, it depends. It's not an easy answer. And if you're in doubt, replace them. Get a break, put it in your, file it away in your head and go, okay, maybe this case, you look at it, it was 400-pound line, it broke at 350. Like, okay, maybe a little early, but I know now. And that's the level of risk I'm only comfortable with. So I'm always going to replace them there. Those are all right answers. The only wrong answer here is, looks good. I'll deal with it later. And not know, and not really evaluate. If you don't know, replace them, particularly if it's an A line. Consequences of an A line failure are way higher than the consequences of a C line failure. Right? Did you guys ever get that in your AFF? A line, you always cut away. I would never land a parachute with a broken A line, even if the controllability checked out. I may not land it with a C. Depends on which one it is. So small parachutes, I'm probably never going to accept a broken line for landings. So
I think that parallels the cultural side of things, like you were talking about it. Like one thing to remind people, especially the students or anyone, whether we're doing 1,000 jumps a year, it's a full time, whatever, or we're doing 200 jumps a year on these campings, it's just over $1-ish a day, a year for a long time. $450, $2, whatever that matrix looks like. But when we remind people it's $1 a day, it's a beer a week sacrifice to replace your line sets versus a broken back or unpleasant surviving broken line.
Yep.
A beer, that's all it costs.
yeah, what you're saying here is I'm going to repeat it for the guys online. Is that the cost is, when you break it down on per jump or per week or per day, the cost is really small. You know, maybe $1 a jump, maybe $1.50 or $2 a jump if you're jumping really high performance stuff. The cost of a beer a week if you're jumping at a normal pace, and so it's really small, and an ounce of prevention is worth a pound of cure, right? And so if you budget that and you know that, hey, look, it just costs me this much. The jump ticket costs this much, but the gear wear and tear also costs this much, and you budget that. It's easier. It's easier to afford, right? And the same thing, pilots do the same thing on airplanes, guys. Like when you fly an airplane, every hour you fly, you should be putting a little bit of money away for a new engine or for maintenance, because this stuff all wears. And when the time comes to do critical safety maintenance, you don't want money to be the thing that makes the decision for you, because that never puts you in a good spot. When money competes with safety, it's a really dangerous place to be in. So, well, thank you for coming. Thanks for talking about lines again. We're going to continue talking about this stuff. But as you're going to see, we're developing, some of our seminars we're going past the whole line thing. And what we're going to continue, though, periodically flashing back to these things. If you have questions, if you have concerns, always bring them to us. We're happy to talk about them. And let's keep the conversation going and keep increasing safety. Did you have a question, or are you just stretching? Okay. Well, thanks for coming out. This is all I have, unless we have more questions. More lines. Yeah. Thank you, guys. Thanks for coming online too, guys.